What is the best way to create a React project within Electron? And what if you want to add Three.js so that you can make a 3D desktop app? With a vanilla React project, it feels like there's lots of good tried and true ways to build apps these days. You got Create React App, Next.js, etc. But with Electron, it's a little bit trickier and not as clear the pros and cons between the different options available to us. So today we're going to dive right into this. Specifically, we're going to be continuing our series on how to build your own custom screensaver. This is part 2 of the series. If you're interested to get a little bit more background on how screensavers really work under the hood, feel free to check out the part 1 of the series. Or if you're just the kind of person who likes to get right into the code, then stick around and yeah, let's build this. Today we're going to be using a library called React 3 Fiber, which is a really amazing tool to combine React with Three.js. If you don't have any Three.js background, don't worry. We are just using plain old React at the end of the day, but Three.js adds that extra spice that makes our project today more interesting. This will allow us to continue building that classic 3D pipe screensaver. All right, let's get this started. We're going to use a tool called Electron Forge to scaffold our repository. You can think of Electron Forge like a Create React app, but for Electron. And this is just because to set up an Electron project from scratch can actually be quite a bit of work. We want things like Webpack, TypeScript, all of that modern tooling, and Electron Forge just makes it really easy to do that. Now, one thing Electron Forge does not have out of the box is a React integration. But the reason for this is all you really need to do is use their Webpack and TypeScript template, and then it's literally just a matter of adding a couple dependencies and configuring a couple files to set up your React project. Alternatively, you might have heard of the Electron React boilerplate project. This project does a really good job of just making it super easy and turnkey to set up an Electron project with React pre-installed. We're not going to use that tool today though for a couple of reasons. Number one, we have a little bit less flexibility when it comes to the Electron side of things. Electron Forge has this really nice plugin system where they have what they call plugins, but also makers and publishers. And this project has existed for a very long time and has done a good job of working out all the kinks when it comes to building an Electron project. And then the other reason is it is really nice to actually learn what's actually happening under the hood if you want to add a React to your project. Sometimes if this is just given to you, you don't appreciate or fully understand what's involved in the setup. And if push came to shove and you needed to tweak something, you have less understanding of what's actually happening. So today we're going to use Electron Forge and then manually add in our React, Three.js, React 3 Fiber, etc. dependencies so that we actually know how this is scaffolded under the hood. We're going to run npx create electron app. We're going to use a special template called the TypeScript Webpack template. And we're going to call this the pipe dream. We're building the pipe dream. Sweet, so we're going to cd into the pipe dream, and then we're going to go down the rabbit hole. All right, so we got our development environment set up here. As you can see, we're using VS Code as our editor. If I pull up our sidebar here, we can see that we have a bunch of files created for us by Electron Forge. So what I'd like to do first off before we do anything is go ahead and create an initial commit with all these files. And this will basically give us a checkpoint so that as we make progress, we can see exactly what changes we've made. So we're gonna go ahead and open up our version control view. And we'll go through each one of these. I highly recommend going through each of these one by one, just so you know exactly what you're bringing into your repository. Right now it's less important because this is all brand new stuff, but in the future, as we make changes, that's gonna be really important. And I'm a terminal guy when it comes to Git. So let's open up a terminal. We'll do a git commit with the message of initial commit. Awesome, so now we have that baseline. So real quick, Electron 101. Electron is made up of two main parts. One is you can think of as the Node.js side of the world, where it actually has access to your file system and everything that Node.js would have, like it would on a server normally. And then there's the renderer side, which is your traditional web view with the code that you would be running in your browser. Electron Forge separates these into an index.ts, which represents our main Node.js code, and then a renderer, which represents the code that's actually going to get run in that browser. So some quick housekeeping things. Let's go to our package.json and go ahead and change our description to something that represents what we're building. We're going to build a Three.js remake of the 3D pipes screensaver. I'm going to change the version to 0.1.0 just because I don't like to claim that this is a stable 1.0 release until I have gotten to that point. Okay, next we're going to add some dependencies. So let's go ahead and bring up a terminal again. And by default, React and Three.js and React 3 Fiber and all those dependencies aren't installed by default, so we're going to need to install those. And since we're using TypeScript, we're going to need to add some types to support them. And we forgot Three.js. You'll never get this right the first time. Perfect. Next, we're going to configure our tsconfig to support JSX elements. Otherwise, TypeScript is going to get real confused real quick. So to do that, we're going to add a JSX React option. And since we are using JSX now, we're going to go ahead and rename our renderer from renderer.ts to render.tsx. And then we'll need to come back to our package.json into our Forge configuration. And we'll just need to update the entry point for the renderer to point to that TSX extension now. Okay, we're gonna get rid of a bunch of this code. Feel free to read this all on your own time, but this isn't gonna be a big focus of this video. We are using React 18 here. So best practice is now gonna be to use the create root method. And this is gonna come from React DOM/client. We're gonna go ahead and go create a root, and it's gonna equal to our create root container. We'll just make our document.body for now, and then we can go ahead and go root.render. So we're going to need an app to render. Let's go ahead and create a new app.tsx file. And in here we can create our entry point to our React project. Don't forget to import React, otherwise the JSX will not work. And now we can render our app. We will also need to remember to import React here. Let's head on over to our index.css and add some styles. We want our width and height of the HTML and body to be 100% so that our canvas stretches across the whole screen. By default, this will not be the case. We can set our background color, and then by default, Forge has added this padding and max width on our body. We're just going to get rid of that so that, again, we can go full screen. Next, we're going to head to our index.html, and we're just going to get rid of this default hello world Electron. Let's go ahead while we're at it. We'll change our title to the pipe dream. Realistically, we're never going to see this title, but for the sake of completeness and best practice, let's do that. We're going to jump to our index.ts file, and we're going to change this to dark mode because we need to set our priority straight. To do that, we're going to do a native theme dot theme source equals dark. And native theme comes from our Electron module. All right, so let's spin this up by opening up our terminal again, and we're going to do a yarn start. For those not using yarn, this will be an npm start. Awesome, so we have a blank page here. All right, we're getting some errors in our console. React is recommending that we don't use document.body as our render target. So let's go back and follow some best practices. And the way we're going to do this is we're going to go to our index.html. We're just going to add a div with an ID of app. And then we'll render into this div. And now if we look at our page, we have our div available. Let's just make sure this works by jumping into our app and just rendering something in here. Awesome, we got our test. All right, so this is working good. So let's go ahead and remove our test. And before we do anything else, let's make a quick commit. We're gonna call this initial setup. Let's pop into our app, and we're going to get our 3D canvas set up here. So let's go ahead and replace our empty fragment with a canvas. Canvas is going to come from React 3 Fiber. To keep things clean, we're going to go ahead and split our scene into its own file right away here. So we're going to create a scene.tsx, and then we'll toss it in our canvas. Splitting the scene out into its own file isn't strictly necessary, but I've gotten into the habit of doing this because as soon as you need to use any of the React 3 Fiber hooks, such as use frame, etc., those hooks need to exist within a child component of that canvas. So if we just default to create a scene as a first child and then put everything else inside that scene, we'll never have issues with those hooks. By the way, I'm going to move relatively quickly as I go through these React 3 Fiber elements. If you are completely brand new to React 3 Fiber, I highly recommend you checking out my other video called I Wish I Knew This Before Using React 3 Fiber. In that video, I do a side-by-side comparison between Three.js and React 3 Fiber so that you can understand exactly what's happening within React 3 Fiber under the hood. Excellent, and let's make sure that's working by adding a mesh to our scene. Awesome, it is, but as you can see, our canvas is not full height. And that's because we just recently changed our container to this app div, which does not have 100% width and height. Let's go ahead and fix that. Perfect, let's add some light. Let's add a perspective camera from React 3 Dry so that we can position our camera as we like. By the way, in my other video, I pronounced it React 3 Dre. I apologize for that. It's actually pronounced dry. and dry is actually the number 3 in German. And let's add some orbit controls also from dry so that we can move our scene around and see what's going on. And let's just adjust our point light so that our lighting looks a little bit better. Okay, let's talk about our game plan here. We're building a 3D pipe screensaver. So one of the first things we're going to need to do here is create a 3D pipe segment that can be reused throughout the scene. 3JS has a cylinder geometry that will work perfectly for this situation. The args ask for the radius top, bottom, height, radial segments, and some other things. So let's go ahead and fill that out. We're going to want our top and bottom to have the same radius. Our height can be 1 for now. And let's experiment with our radial segments. So we've created 5 segments here. Let's go ahead and increase that so this looks more like a cylinder. I think 20 is reasonable for now. Let's add some color to our tube, and we'll make this light green. Gotta be color coded. And we have a decent looking cylinder, so let's go ahead and pull this out into its own file. By the way, you might have noticed I haven't been spending too much time on folder structure. For example, often you'll create a components folder. And as developers, we like to really get caught up in this kind of thing. And I think it's very important, especially when you're further along in the project or you're on a team. When you're working in the team, one of the most important things is to be consistent across the board. But in our case, we're just getting started here. We're kind of in that creative phase where we're just kind of poking around, experimenting, still trying to figure out exactly how we're going to build this. And in my opinion, this is a perfectly acceptable time just to get the basics started, as long as we have plans to organize things as we go. And I find as you're programming, it really is a balance, right? At the beginning, you're in that more creative, it's kind of more messy phase. But then later on, you really need to be focusing on folder structure and organizing your code in a way that will make sense. And this is a great time to make a commit. So we already forgot to commit back when we did our initial canvas. I think that would have been a nice checkpoint. So let's pretend for a second that we haven't created our pipe yet and just commit that other stuff first. So we'll stage app, we will stage our index. We're not going to stage our pipe, and we're going to need to stage our scene because we reference it in our app, but we really don't want to commit this pipe yet. So the easiest thing is probably just to get rid of our pipe temporarily. And we will commit that, and then we'll just quickly undo that. Fun fact, in VS Code, you can actually partially stage things within a file. So say I had another mesh here, and I wanted to stage just this mesh but not my pipe. You can actually highlight this and go stage selected ranges, and that would stage just that portion of the file. This is actually a game changer in some situations, so that you don't have to do this song and dance of deleting code and then undoing it. So we're going to commit that as initial scene, and then we're going to go and commit our pipe. Pipe proof of concept. And now we can see we have a nice, clean, logical commit history. Okay, so we're going to need some way to scale this cylinder up. Obviously, this is looking a little short. And in our 3D pipe screensaver, these could really be any length. So this is something we're going to need to make dynamic as well. So there's 2 main options to make this thing grow. One, you might be thinking, okay, well, the args accept a height as one of the parameters, so I can just go ahead and change the height to something larger, and that will go ahead and change the height, and that works, of course. However, if height is dynamic, and this is potentially something we'll be changing quite often, like what if we wanted to animate the height, then in 3JS it's really not great practice to be modifying your geometry because it actually has to recreate that over and over again. So a better strategy would be to leave that back at 1, and we're going to go ahead and just apply a scale to our mesh. So in the X, we'll just scale at 1, so multiply by 1, won't change at all. We'll scale the Y axis by 10 and the Z by also just 1, and then we achieve the same result here. Now, since we don't actually care about scaling the X and Z factors, another option here is we can do what's actually called property piercing, where we can pierce into nested properties within our 3JS instances. In this case, our scale is actually a vector 3, right? It's a vector 3 that accepts an X, Y, and Z value. So vector 3s themselves literally have an X, Y, and Z prop on them. So the idea here is, wouldn't it be nice if there was some way we could target this Y property directly rather than having to rechange the entire vector 3? And this is where piercing comes in. So instead of setting the scale this way, we can instead say scale dash Y, equals, and then set that to whatever we want our scale Y to be. And so it's this dash notation here that allows you to do piercing. And you can pierce into nested properties infinitely. Pretend Y had its own sub-properties. You could say Y dot whatever, right? You can keep going. In this case, Y itself is a number, so you wouldn't be able to go any further. So if we get rid of our scale and just keep our scale dash Y, we can see that that still worked. And just to prove that I'm not doing anything magic here, I can change the size. Looking pretty good. Now, the only one downside from a development experience with this is you lose some type safety. If I get rid of this 10, you can see it doesn't know what this type is, and understandably, right? This dash convention is a special feature that React 3 Fiber built into their library, so TypeScript has a hard time of knowing that the dash means that this is going to a nested property. At this time, I don't believe there is a way for TypeScript to understand this, but perhaps it will in the future. All right, so now that we have the ability to set our height dynamically, let's break this out into a prop. Another thing that would be nice here is the ability to animate the pipes as they're added to the scene. So you can imagine their height would animate from a 0 height to the full length of the pipe. And this will just look a lot better than each pipe segment popping in one go. So this is a great opportunity to use another library called React Spring. I've talked about React Spring before. React Spring allows you to do animations in a more declarative way. Unfortunately though, we have run out of time in this video today. I hope this video helped you scaffold your Electron repository with React 3 Fiber. In the next video, we're going to continue right on here. We're going to jump right into those declarative animations and how they work under the hood so that we're actually able to learn how they're able to still be performant within React. And then we're going to talk about how to actually change the pivot point of a mesh within React 3 Fiber, how we can more or less extend a React 3 Fiber group within our own components, and then jump into a whole lot of other things in order for us to continue to build this 3D pipe screensaver. Thanks for watching, and I'll catch you down the next rabbit hole.